Today we're going to start off by reviewing some organic chemistry stuff. Just a little bit of humor to start off. There's a love-hate relationship between chemistry students and organic chemistry. But there's patterns to naming, there's patterns to drawing, which, if you understand those patterns, organic chem is fun. If you do not understand them, it is the most torturous subject you will ever do. First of all, do you remember your Lewis dot structure for carbon? Yes. What does it look like?
Something with a lot of dots.
How many dots? Why 4?
Because each level
Mm-hmm.
is in the fourth.
Okay, so please recall that carbon has 6 electrons because there's 6 protons. So if I were to draw the Bohr model, it would look like this. When we draw a Lewis dot diagram, we only show the electrons which are in the uttermost energy level. Do you remember the name for those? Okay, valence electrons.
Valence electrons.
Why am I only going to show valence electrons in Lewis dot diagrams?
That's the rule.
Okay, yes, that is the rule, but why does that rule exist?
The L layer of electrons attract other electrons.
Okay.
Because they don't always have to.
All right, so these electrons are the ones that are involved with bonding. They explain why chemical reactions happen. They explain why certain things combine with other things. We're not forgetting that there's these 2 electrons present. We're just saying, you know what, those 2 electrons right here aren't going to do very much for us. What is going to be important are these 4 valence electrons, which are available to form a bond with something else. Okay. Yes, you are correct. There are 4 valence electrons in carbon. Do you remember what the octet rule is?
You always need to have 4,
No?
8.
Octa?
8.
8. The rule of 8. 8 valence electrons. Means what?
You must have 8.
Why would something want 8 valence electrons?
It can be like a normal gas.
Pardon?
So it can be like a normal gas.
Exactly. Okay. So if I have this structure for carbon, and there is only 1 carbon, and the rest is hydrogen, how am I going to figure out how many hydrogen I need to combine with that?
8 subtract 4.
Okay. So each hydrogen can share 1 electron. So in this structure, I can add 4 hydrogen. By sharing 1 electron with carbon, now we have 2, 4, 6, 8 valence electrons around the carbon. However, hydrogen only has how many valence electrons? 2.
2.
Okay. Why does the octet rule not work for hydrogen?
It only has 1 layer of electrons, so it only can have 2 mass.
That's right. Hydrogen only has 1 electron shell. Only 2 electrons can go into that shell. The octet rule will never work for hydrogen. But for all the other things that we're going to use in this unit, we want to make sure that there's 8 valence electrons around that structure. Generally, I won't put dots where a bond exists. Instead, I'll use a line. So, for example, here, that line is equal to 2 dots or 2 electrons. I can even take this one step further. Oftentimes in organic chemistry, a chemist will not even bother to show you the hydrogen that's at the end of those lines. They will just assume that you know. If there's a line extending from carbon without anything on the end, it is automatically hydrogen. Lovely. Why does the octet rule matter?
Because everything wants to be like a noble gas and have all its valence electrons still.
Why does that matter to us?
So it can be, so it can be stable.
Oh, yes, stability is important. Why else does that matter to us? It's going to help us to predict the formula and the structure of that particular substance. Do you remember the difference between an alkane and an alkene?
Alkane has only single bonds, and then
Yes.
alkene has one double bond.
Okay, so alkane, alkene, when you say single bond and single bond and double bonds between what?
Each other.
Each other? Okay, what is each?
Carbon.
Carbon. Okay. So for example, that would be an alkane because there are all single bonds between carbon. This is an example of an alkene because there is one double bond. At this point, I'm not going to mess with you and put more than one double bond in a structure. That could change. How would I figure out how many hydrogen have to go in each of those structures?
The equations, the C.
Yeah, I could do the equation. Do you remember what the equations are?
The first one C, H it has a 2-1 bond, 2 plus 2.
Okay.
Or,
So that is your alkene formula, which shows you your ratio of carbon to hydrogen. If I have 3 carbon, how many hydrogen atoms should I have? 8. Where do I put those 8? Where am I going to put those 8 hydrogen? Am I just going to go 1, 2, 3, 4, 5, 6, 7, 8?
You're just gonna put them
No, you're gonna put, yeah, to the sides that are available.
Okay.
Each one can hold 4.
Ah.
4.
Now you're thinking of the octet rule. Remember that each bond equals 2 electrons.
Or 8.
The octet rule says that I need 8 electrons. Therefore, how many dashes should I have extending from every single carbon? 4. So I only have 1 dash between this carbon and the next. I need to add 3 hydrogen to that first one. On the second carbon, I have 1 dash, 2 dash. How many hydrogens am I adding? What about this last one? 1, 2, 3. Do you remember the formula for an alkene?
Just H2N.
All right, CnH2n. Which means that if I have 3 carbon in the structure, how many hydrogen do I need?
6.
6. Where are those 6 hydrogen going to go? Mhm.
2 on the first one,
Yes?
1 on the second one, and then 2 on the last one.
Okay. Each carbon can have 4 bonds extending from it. On this first carbon, there's already 2 bonds, which means I can only add 2 more hydrogen to the first one. On the second one, I have 1, 2, 3 bonds already, which means the fourth one must be bonded to a hydrogen. Here, I have 1 bond between carbon 3 and carbon 4, which means I need 3 hydrogen to get me up to the 8 electrons that I need to fulfill the octet rule. It's all about the 8. Do you remember how to name these? Ooh, how do you name?
Our yellow booklet.
Your yellow booklet, page
4.
4, gives you your organic prefixes. The first 4 are different than the molecular compound prefixes that you have used previously. How many carbons are there? 3. The prefix for 3 is prop.
So it's propane.
This is propane.
Propene.
I add ANE because it is an alkane. This is still prop because there are 3 carbon.
But it's propene.
It's propene because it is an alkene, so that is the name ending that it receives. How are you doing with that stuff? Do you have a headache yet?
No, it's actually starting to come on for some reason.
Okay. It's starting to work its way through the turkey haze. What if I were to give you the word butane? Can you please draw what the structure would look like? The word is butane. Can you draw what the structure would look like? But means what? 4. Ane tells you single bonds. So the first thing I would do is draw 4 carbons connected by 1 line. How many hydrogens should there be in this structure? So 2 times 4 is
8
plus 2.
It's 10.
There should be 10 hydrogen in this structure. How many hydrogen can go on the first carbon? 3.
2, 2, 3.
On the second carbon?
2.
Third column? Fourth?
10. Just kidding. 3.
How did you do with that?
Good.
Good. If I gave you a structural formula, CH2, CH, CH3, can you draw that out? Yeah? Oh, come on, you can do it. Let's see what he came up
You
with.
add the
All right.
Yeah, I know. I drew it already. But I probably got it wrong.
My real name's actually Karma. I accidentally did that. What?
Am I supposed to draw it?
What do you think?
Oh, I think that you have one too many double bonds there. So.
Yeah, that's what I think.
Okay, so
You
according
have 6
to,
bonds in the middle.
Oh, oops.
according to this first structure, you should have
That's
C
tough.
and then 2 hydrogens. 1, 2, you've got that correct. Then comes the next C, and how many hydrogens should you have?
1.
You have placed 2, so I'm going to erase this.
Oh, yeah. Oopsie.
Then, on this third one, how many hydrogens should you have?
3.
Okay, so please add another hydrogen. All right, let's think about the double bonds. Are the double bonds correct?
No,
How do you know?
because then you would only have 4 hydrogen.
You mean 4 lines extending from each carbon. Are there 4 lines extending from each carbon? Which double bond is wrong, the first one or the second one? Second one. Okay. There should actually only be a single bond between that. The challenge with structural formulas is you will not be able to see from CH3, CH, CH3 if there's a double bond or not. You have to count in order to figure out if you need to add a double bond or not. Questions, concerns at this point? We've gone through that in 15 minutes. That's pretty fast to review 4 classes of chem.
So we're doing good? Yay! Why doesn't anybody else cheer? Oh. Let's high five myself. Fire high five.
Don't do it.
Let's do it.
Today,
No.
we are going to look at branches. We are still dealing with straight chain aliphatics, but instead of having one singular chain, we will have small little bits extending from that main chain.
I need one of these things from the kit.
Oh, I will add that back to the kit. Thank you, Michael.
Sitting right there.
Okay, if you take a look at this structure, any suggestions of what the name could be?
Butane. Butane.
Pentane.
Butane.
It is actually a type of butane.
My longest stretch is 4. Do you know the naming rules?
The correct name for this is actually 2-methylbutane. Any suggestions for where on earth I am getting that name from?
You have only one, you have one branch.
Yes.
That's where the meth comes from.
Yes.
I don't know where the YL does, so.
Okay, Taylor?
I am just looking at the thing here. It says you name the branch with a YL. So, yeah, the second branch, there's 2 carbons, so methyl, and then the butane.
Okay, close. You're getting really warm. 2 is a street address. What is the street address for?
Tell you where something.
It's for the branch. Okay. If I number the longest chain possible of carbons, I got 4 carbons, right? I can go 1, 2, 3, 4, or I can go 1, 2, 3, 4. I can go backwards and go 1, 2, 3, 4, but the longest chain is 4 carbons. That is how I get the word bute. Are there any double bonds within that chain? No. That's how I get ane. The 2 comes from numbering the big branch and identifying where the little branch comes off. This branch comes off of carbon number 2 in the big chain. That is a street address. Il indicates a branch. Whoop, that doesn't show up well. I'll switch to red here. Anytime you see the ending YL, it's a branch off of something. So where does the meth in front of L come from? The number of carbons in the branch.
What should it be? What if you chose to go backwards?
So if I chose to go 3-methylbutane, that would actually be an incorrect label because it is a flipped mirror image of 2-methylbutane. I always go for the lowest street address. And the lowest street address puts that branch on carbon number 2 rather than carbon number 3. But you still have to consider numbering forwards, backwards.
So if that branch was one more over to the right, then you would suggest going from the left to the right?
Exactly. Exactly. So if you're not catching what Spencer suggested, if this was moved over here, so it's no longer joined there, it's actually still 2-methylbutane because now I'm going to number backwards because that gives me a lower street address than calling that 3-methylbutane. So, first step, always find the longest continuous chain of carbon atoms. It does not have to be in a straight chain. We're going to call this the parent. Okay. This helps to distinguish between long branch versus short branch. The parent is the longest continuous branch of carbons. This is the original structure. You have to consider all directions. What I mean by that is you can go forward, 1, 2, 3, 4. You can go backwards, 1, 2, 3, 4. You do not have to stay in a straight line. I can go 1, 2, 3, 4, or 1, 2, 3, 4. But my longest continuous branch, the parent, is 4 carbons long. That's where I suggest that you start off. State the number of carbon atoms using the appropriate prefix and ending with A and E because there's no double bonds here. That means that you are identifying the parent branch as butane. Identify the parent branch first. Branches are called alkyls, just a fancy chemistry name for a branch. This reveals why they have the YL ending on a branch name. Number the carbon atoms in the parent branch, starting from at the end that's closest to the branch. So for example, the branch is down towards this end, so I'm going to call this carbon number 1, carbon number 2, carbon number 3, carbon number 4. And I actually write down the carbon number right on the diagram to help me through this. Name each branch, and you have to give it a street address. So this is a 1-carbon branch. The prefix for 1 carbon is meth. Add the YL because it's a branch. This goes before the word prefix. The last step is to indicate the address of that branch.
If there was more going along with that CH3, would it still have the YL after it?
Yes, it would.
So if there was 5, if there was, let's say, 3 more carbons going this way, would it be propyl?
It could be, but I want you to think about that for a moment. Okay, let's get out of this presentation. I'll call up a new slide. That's a really good question. Let's play for a moment. Okay, I need to go insert. It's not letting me.
I don't care. Whatever, they're sweet.
All right. Go back to the slideshow from the All right, so Spencer's question was, let's say we take our chain, 3, 4, 1, 2, 3, put in the hydrogens, and the suggestion was to name this as a purple branch. Now, if we're just sticking strictly with a 3-carbon branch, yep, he would be onto something. However, that's actually not the correct identity for this particular molecule.
Because can't you go like 7
Oh, where did you get 7 from?
by going across 3 and then down 4?
The longest continuous branch, the parent chain, is no longer bute. The longest continuous chain is now 7 carbons long.
Okay, I see.
1, 2, 3, 4, 5. 6, pardon me. Not 7. 6 carbons long. So what is the prefix for 6? Hex. Next comes the numbering. So carbon 1, 2, 3, 4, 5, 6, or carbon 1, 2, 3, 4, 5, 6. Which numbering am I going to use?
3.
Yes.
Couldn't you go over from left to right?
What is the name of that branch?
Methyl.
Methyl.
Over from here?
No, because that's the.
So your question ended up being actually a little bit more complicated than that, Spencer.
Couldn't you go 1, 2, left to right with the carbons?
1, 2. So can I go 1, 2, 3, 4?
No, 1, 2, 3, 4, 5, like you did
Um,
going this way.
1, 2, 3, 4, 5. Yes. But is that my longest possible chain? No. When you name your parent, you have to go for the longest possible chain before you decide what's the chain and what are the branches. This is going to get beautifully complicated.
No!
Oh, yes. Because you can have more than one branch.
Yeah.
Let's go back.
If you have more than one methyl branch, you have dimethyl.
What if you have more than
I'll give you an example of this.
Yeah.
Let's say that right here, I add
I'm not looking at
that.
wasting time.
Okay?
What happens now with the number in front?
Okay.
Is it 2 or 3?
What's the longest number, or what's the longest continuous chain of carbons?
6.
Are you sure? Can I go 6 carbons in a line in a
I
row?
thought you just said the longest chain was 6.
Longest continuous chain.
Oh, then I don't know.
I can't go 1, 2, 3, 4, 5, 6. It would need to be attached. It's still 4, right? So it's still butane. What are the addresses of the branches?
2 and 3. 2, 3.
Each branch has how many carbons?
1.
So the prefix for 1 is
Dimethyl butane.
methyl And because there's a methyl group here and a methyl group here, it would actually be dimethyl butane. So this is just delightfully and beautifully complex.
I have a question that's kind of related but not really. So
Okay.
do methamphetamines have one
No, it's
carbon
just
in
new
them?
in future classes.
Say that again?
Something
Do
has
like
a 90 and
methamphetamines, do
above
they have like
in
one
this
carbon
class,
in them?
they can
Is that why
skip
they're
at least
called
one
meth
unit.
to start?
Methane is just one carbon. Now, are you talking about crystal meth?
Yes.
That's different.
Yeah.
Because meth in that case is short for methamphetamine.
Oh.
So,
Wondering if it's
Why are you
no. Different structure entirely.
Okay, I was wondering if it was similar or not.
No, fair enough question. Honestly, it gets asked every year. So it's not like your brain is doing something strange. What if the structure was two, oh sorry, okay, so we have 2, which is the street address, dash, methyl indicates the branch, butane indicates the parent chain. If we have more than one number, we have to put a comma between the numbers. Identify your parent chain, number the parent chain, name the branches, name the compound. Here's a structure for you to work with. You might want to draw this out to the side so that you can see it a little bit better.
Are we just supposed to draw it?
It's very hard to see it in a condensed form. I would suggest that you draw it out so that you can see it easier.
Guessing it's 2, 3, 4. Try it.
This should be equal. 1, 2, 3, 4, 6. There's 3. 1, 2, 3, 4, 5, 6, 7.
Have you found the longest continuous chain yet? How many carbons are in the longest possible continuous chain? 5 carbons. Do you see it? Carbon 1, 2, 3, 4, 5. So remember, you have to look in all directions, backwards, forwards, anything that's linked, and find the longest possible continuous chain. Question?
Yeah, I'm not 100% sure. How do you get the numbers in front? For example, like with the previous one, it was 2-methyl butane. How do you get to 2?
That is telling you the number of the parent chain the branch is coming from. Okay, so let's name the parent chain first. The longest possible chain is 5 carbons, all single bonds between carbons. Therefore, it's question.
I was just wondering, so, like, if you have it numbered, right, it's from 1, 2, 3, 4, 5. So if I start out with, like, 2, because that's the shortest one, right? Like, that's where I'm starting from is with 2. I have to keep going that way from where I started from, right?
Yeah.
Like, I can't turn around and be like, oh, well, if I go from this way, then that one's...
The only way that you could turn around is if this was actually attached to this carbon, and it would allow you to do a circle.
Oh,
But these are actually 2 different hydrogen atoms that are not connected.
okay.
So no, you can't count like that. So we have a 5 carbon chain. The prefix for 5 is pent. All single bonds between hydrogen is ane. Now let's take a look at our branches. We have a branch here, a branch here, and a branch here. Each branch has how many carbons?
1,
1. So what is the prefix for 1?
meth.
Methyl. Because there are 3 different 1 carbon branches, we say trimethyl.